Okay, so this class is about pairs trading. But in order to talk about pairs trading, we first have to discuss the term stationary. So let's start with stationary. Looking at this graph, and let's say it's some sort of time series. Forget about stocks, it's just a time series. But what you can see about this time series is that the average is not constant, right? We have a trend, the average goes up. So if we look at the moving average in every section of this graph, we'll see that it changes. So we can say here that the average is not constant. Okay, cool. So let's look at this sinus wave. And let's say we have a sinus wave that is not symmetrical, right? The frequency here changes. That means that the width of each cycle is different than the previous one. So if we look at the average at this sinus wave, we can see that the average here is around 0, right? It could be 0, it could be around 0. But one thing we can say for sure, that it's constant. So over the life of this signal, the average is constant. It stays the same. What if we want to look at the variance? So as you remember, the variance is the average of the distances from the mean of each point of this signal, right? So we measure the distance from the mean from each point and we make the average of it. But if we look at the variance at this section or at the variance at this section, we will see that the variance will be different. And the reason is that because this sinus wave is not symmetrical, so the average of the distances from the mean for each section is always going to be different. So although we said that the average is constant here, we can say for sure that the variance will not be constant. So how about this one? Let's say we have a pure sinus wave, and forgive me if it's not really looking pure, but I will try my best. So if we have a pure sinus wave, we can assume that, first of all, the average is, in this case, 0, right? Because this sinus wave revolves around 0. So let's say that the average is equal 0. But what about the variance? So as we said, the variance are the distances from the mean. We measure the average of the distances from the mean. So if we measure the average, the variance in this period, and we measure the variance in this period, we're actually going to get that they're equal. And why is that? Because the area here of the first variance, as you can see, the distances from the curve and the variance here are going to be the same, right? We have one full cycle on the bottom and 2 half on the top. So wherever you measure the variance, we're going to get a constant variance, right? Whatever period we choose, we will get constant variance. So what we can say about it is that this curve, this sinus wave, is stationary, because in order for a wave to be stationary, we need to have the average constant and the variance constant. So the first one is not stationary, right? Because the average is not constant. We have a trend. The second one, we have the average constant, but the variance is not constant, right? So we can say this one is called not stationary because we need both of them to be constant. But the third one, the average is 0, constant, and the variance is also constant. So we can say that this pure sinus wave is defined as stationary. So why stationary? Why does it matter? Why are we looking for stationary time series? So stationary time series, as we said, have the average and the variance as constants. And once the average and the variance are constant, our time series, our signal is much more predictable. And not only it is more predictable, we can apply many statistical methods on it just because it's stationary. We will see this later, but in general, you want your signal to be as close as possible to a stationary time series. So if you remember in the previous classes, we said that if we have just a normal stock price, it has a trend, right? So the average is not constant, and also the variance is not constant. So what we do, we are going to take each point here and we're going to calculate the difference between each 2 points, which give us the returns. So if we sketch here a returns, the time series as the returns of the stock, not as the price, what you see here is that we get something that is more stationary. So a price itself is not a stationary time series, but the returns are revolving around zero and have somewhat variance, have a variance that is somewhat constant. So the returns are actually much more closer to be stationary. So we can see here that the mean, the average is somewhat close to zero, which means it's constant, and the variance, which is the distances from the mean, is also very close to be constant along this time series. So let's say that we have this competition between two people, and let's say the y-axis is the height, how high they climb, and let's say the x-axis is the time. So we have 1, 2, 3, 4, 5 minutes. Every slot is 1 minute. So these two people, they have a competition, and we're going to look at the speed of their climbing. So let's say Bob started to climb very fast and he climbed pretty high. But the other person, she started slow, so she climbed half of the height than Bob. But then she gained some speed, she had more energy, so she climbed higher in the second minute. Now Bob was a bit more tired, so he climbed a bit slower, so he gets somewhere around here, and then he wake up, get more speed, so he get higher, and the other person, she get slow, so she finished somewhere around here. So they climb in different speeds, right? But uh, the distance between them stay pretty much constant, as you can see here. So if we create this table here, we can say that constant speed. So none of them have constant speed, right? Because they climb in different speeds during this time period. Now let's see the variance. Is the variance is constant? Also no, right? Because each one of them have different variance because the average of the speed changes. So of course we cannot say that any of them is stationary, right? Because the average and the speed are not constant. But one thing we can say is that the distance between them, it stayed the same, it's constant, right? So we can say that the average distance between them is equal. And because it's equal, we can say that the distance between them is stationary. But what if instead Bob and Hannah, we will have two stocks? So let's say we will have SPY here, SPY, and Amazon. So we can say here that these two shares, each one of them move in its own pace, right? It has its own speed, but the spread between them or the distance between them stay the same. So we can say that none of them by its own is stationary, right? But if we look at them as a pair, if we look at the distance between them, they are moving in a way that the distance is constant. So we can here start talking about pair trading. So let's say we have these two shares. So if we continue the same idea, we can say that instead of looking at each one of them individually, we can look at the distance between them. So looking at the spread, which is SPY minus AMZN, we look at the difference between them instead of look at each individual share. We can see that the average is constant or close to constant, and the variance is also close to be constant. And as we showed, this spread will be stationary. Looking at the spread, as we showed, because the spread is somewhat stationary, and if it's stationary, it has a constant average. So if the average is constant, we can assume that it has this tendency to revert to the mean, to the average, right? So this red point will tell us that the spread is too high currently, and this one says that it's too low, right? Because we know that it has this tendency to revert back to the mean. So we can say that the spread, let's write the equation, that the spread equals, in this case, SPY, right, the first share, minus AMZN, which is the other share, Amazon. The first red point, we can see that this point is higher than the average. So we assume that this spread is going to go down, right? Because it has to revert to the mean, and we're too high now. So what does it mean? So looking at this equation, it means that SPY has to go down, right? Because the spread has to go down. So SPY should go down and AMZN should go up. Looking at these two green points, we can say, look at the first one. So here we can say that the spread is too low, right? And we assume it has to revert back to the mean. It has to go up, right? So in this case, if the spread goes up, so we can look at the formula again, and we can easily assume that in this case, SPY should go up and AMZN should go down, right? Looking at the first point, the first example, we realized that we expected the spread to go down. So in this case, we expected SPY to go down, right? So we're going to sell SPY. And we also expected AMZN to go up. So we will buy AMZN, right? And if we look at the other example here, it was too low, so we expected the spread to go up. That means SPY should go up. So we will buy SPY and we will, of course, sell AMZN because we expected to go down. So this idea is called pairs trading, where we trade the spread of two shares. Now, all of this based on the assumption that the spread is stationary. So we need to find two shares with a stationary spread, right? So this idea called co-integration. Co-integration means that we have stock A, which is not stationary, right? It moves in different speeds and the variance is not constant. And also stock B by its own is also not stationary, right? So each one of them individually is not stationary, but the combination between them, any linear combination between them, like add them or subtracting them, will provide the spread, and the spread should be stationary. Now, it will not always be stationary, but we're looking for a way to find if it is stationary or not. So to do that, we are going to use a special algorithm called the Dickey-Fuller. So using this Dickey-Fuller, we will get a result that we want it to be as small as possible. It's not a binary result, but we want it to be smaller than 0.05. And if the spread result is smaller than 0.05, we know that the spread is stationary and we can use it for pairs trading. So let's see how all of this looks in code. Start by importing class 5 module, which is this class. And here we start by importing the API module, which is the module to get historical data. We programmed it in the first class. You can go ahead and watch it. Next, we have import pandas and numpy, which allow us to handle and create data frames. And next, we import the matplotlib, which let us visualize stuff, and then we import the stat models. Stat models is a very powerful library which you can use for many things. In this case, we're going to use it for the Dickey-Fuller test. So we import the add-Fuller, which is the augmented Dickey-Fuller library. So we start by defining the dates period, which should be long enough for this test. Then we turn the dates into objects as we do usually. And next we are getting the data. So we have S1, S2, two stocks, and we are using the get underline function that we programmed in the first class. and we give it the ticker. So in this case, we will use SPY and AMZN, which are the tickers we use in the sketchboard. So we will provide the dates period and the unit and the interval. In this case, we are going to look after daily interval, which means the close price of every day. So here we are going to calculate the spread, which is basically just subtracting the close price from S1 minus the close price of S2. This is the spread we just learned about. So once we have the spread, we are going to use the add fuller. We're going to provide it with the spread, and we want to test the stationary of this spread. So add ADF test will hold the test results. ADF statistics at 0 will have a set of results, and we are interested in the p-value. This is the value that tells us if the result, the spread, is actually stationary or not. We want it to be smaller than 0.05. Here we just create a data frame with S1 and S2 prices and the spread, just so we can see. We print it, and later we plot the result to see it visually. So let's run this and see how it looks. Well, this is the data frame, and we can see here that this is the Dickey-Fuller result. So we get 0.04, which is smaller than 0.05, which is somewhat a good sign that this spread is stationary and we can use it for pair trading. Here you can see that the columns of the data frame just add the prices and the spread. Let's see how the plot look like. So this is the plot, and you can see that it's going in cycles around a certain constant line, which will be somewhere around here. That will be the average. So we can say that the average here is pretty much constant, and we can see that we also have somewhat mean reversion around the mean, which is good for us. So this is the spread mean and the spread standard deviation. What we want to do is to find the mean, the average of the spread. So we are using the rolling function, which will take each data point and look at the previous 20 data points. In this case, window is 20, and we will calculate the mean, the average for the previous 20 points. So for each point, we look at the previous 20 and calculate the mean. We do the same with the standard deviation because we want to find the moving standard deviation for every point. So we will look at the previous 20 results, each point, and calculate the standard deviation. And then we will create two bands, the lower band and the upper band. So the lower band will be the mean minus the standard deviation, right? And the upper band will be the mean plus standard deviation. If you don't understand that, look at the previous class about Bollinger Bands. The reason we do this is because we want to know how to make decisions around the spread. So here we add the upper and lower bands to the data frame in order to see it, and we want to visualize it also, so we add the lower and upper band to the plot. So let's run this code now and see how the plots look like. So this is the plot. As you can see, this is the lower band, the kind of blue here, and the purple here is the upper band. And what we want to see is wherever the spread get out of the band, out of the standard deviation area, that means that we're not normal and we are expecting it to revert back to the normal. So here it go out from the top, we expect to revert back to the normal. And essentially these lines will be used in one way or another to make decisions about when we want to enter a position and when we want to exit a position. Here we just see the data frame, so we have S1 and S2, those are the two shares. We have the spread, which is the difference between them, and lower and upper band. So the first 20 results are none, as you can see, from index 0 to 19, because we chose a window of 20 for the moving average. So let's now try to create some sort of backtesting function, backtest, and we give it a data frame. We want to check if our strategy works. So we will give the backtest function the data frame, which has the prices of S1 and S2 and the spread. And it also have the bands, the lower band and the upper band. And we are going to try to create signals based on that. So this is the backtest function. It gets the data frame that we just showed. As you can see, it's not very big. Um, so it gets the data frame with the spread and the bands, and we have a state machine here. So the first state is idle, and then we create a new column called profit, which is 0 now, and we are going to iterate each row of this data frame. Of course, there's other more efficient way to do it, but this is more clear. So each iteration, we're going to get the row and the index, and we are going to test our signals. So first we define for each row the P1 and P2, which are the prices for each of our shares. And then we're going to define the spread, which is row at spread, right? The spread of two of them. And we're going to define here the lower and the upper bands, right, that we just showed before. We start with the state idle, right? This is the first state, and here we are waiting for the signal for the spread to be between the upper and lower band. We don't want to proceed taking any position before we are between the bands. So we ask when the spread is larger than lower and spread is smaller than the upper, right? We want the spread to be between them before we change the state and ready to take any position. So assuming the state changed to be empty, like there is no state, next, this else condition will happen because the state is not idle anymore. So we are ready to take a position. So once we get our next iteration and we are inside this else condition, we're going to check one of the two, or we wait for the spread to be lower than the lower band, right? In this case, you can see that the state is stateless, the state is empty. So we first wait for the spread to be lower than the lower band, or we are waiting for the spread to be larger than the upper band. In both cases, you can see that the state is empty, which means we are between the bands and we wait for the spread to cross the lower or the upper band. So let's look at the first one. So here we wait for the spread to be to cross the lower band from the top. So it should be under the lower band. What happened? That means that the spread is too low, and we expect it to go up because of mean reversion, right? So if the spread go up, mean that we expect P1 to go up and P2 to go down, right? So we buy P1. This is why we have a negative sign. We buy, we pay, so the price is negative, and we sell P2, which means we get money, so P2 is positive. So we have P2 minus P1. That's the profit at that point. And we mark this on this column for profit. And next, we are going to visualize this. So we just add a point on the plot. So you can see, and here we change the state to in lower because we're inside the lower band. So this will be used later. And here we do the same, but on the other side. So we expect the spread to be larger than the upper band. If it happens, that means the spread is too high. We expect it to go down. That means we expect to sell, right? To sell P1. So we get money for P1. So it's plus, and to buy P2. So it's minus P2. Here we change the state to in upper because we are inside the upper band. So at the end of these two states, we are going to be or in the in lower or in the in upper state, right? We cross the upper state or the lower state. So next, we're going to be or in lower or in upper, right? Or we cross the upper or we cross the lower band. So let's check what happened in the first one. So if we're in the position of in lower, which means we crossed the lower band, the spread was under the lower band, we are going to exit this position. So how do we exit it? We're doing here P1 minus P2, right? So why? Why? Because now we sell P1 because when we are under this band, we bought it. So now we sell it back, we exit the position, and we buy back P2 because when we were under this band, we sold P2. So we mark this as the profit. And we change the state back to idle because we wait again for the next time to be between the bands before we take a new position. And here we do the same, but on the other side. So if we were in the upper band, which means we crossed the upper band from the top, now we wait to get back under the upper band. And if this happens, we are going to mark P2 minus P1. And the reason is because we are going to sell P2 because we bought it before, right? And we're going to buy back P1 because we sold it when we were on the top of the upper band. So once we do that, we mark this in the profit column, and we will also here change back the state to idle because we wait for the spread to be between the bands before we able to take a new position. And here we just summarize the profit column because we want to just find out what is the total profit from all the positions we took. Okay, so let's now run this backtest function. As you can see, we call it here. So let's run this function and see what we get. So as we can see here, each point, green color means that we enter a position, and red color we exit the position. So you can see here we were waiting for the signal, the spread to be between the bands, right? Until we are crossing here the upper band, the green point here. So once we cross it, we enter the position, we have a green point, and then we expect this spread to go down because we cross the upper band, and indeed it went down, but it actually went down so much that it crossed also the lower band, which is a problem. We will see how to solve it later, but we exit the position right here. Now we cross the upper again, so the green point, and we expect it to go down. Indeed, it went down, and we keep taking positions like this, some of them profitable, some of them not. But as you can see, it's a bit noisy, right? And one of the things we could do is to make the upper band and the lower band a bit higher. So we could choose, instead of one standard deviation, we could choose 2 standard deviations, and then we will take less positions, but the situation will be much more stable. So let's look at the data frame and see how it looks. So the first thing we see is the profit is 28.62. This is the total, the sum of the profit from all the positions in USD. But this is in case we bought or sold one stock on each position. This is the profit column. So let's focus on this one. Let's focus in this case on index 28 and 29, and let's see what happened here. So if we look at this and go back to the curve, let's zoom into index 28 and 29. And you can see that in index 28, we cross the upper band and we enter a position, right? And on the red point right after that, we went down and exit the position. So we expected the spread to go down in this case because it was too high. That means we are selling P1 and we are buying P2, right? That's what we said. So in this case, we can say 397, it's plus, right? Minus 96. The result is 301, right? Because again, we sold P1 or S1 in this case and bought S2. Now, this is S2, so we bought it. That means we did 95 minus 391. So it's minus 96. So you can see here that we had a profit of around 5, right? Because this is the sum of this position. Let's zoom in into this area and see something interesting here. So you can see that here the spread crossed the upper band and we took position the green point, and we expected it to go down because mean reversion, right? What happened is that when it crossed the upper band again, it actually was higher than the initial position, which means we took loss because we expected the spread to go down. And this happened because the stock went up very aggressively. So we took a loss in this position. Now let's see what happened if we change the window of the moving average and the standard deviation. So currently the window was 20, right? We looked 20 days into the past in order to calculate it, and the profit was 28.62. Now let's change it to 10. It's a shorter window. See what happens. So you can clearly see that we get a much lower profit, which is 18.62. That means this window is less good for us. Let's go back now and make the window actually higher. It was 20, we went to 10, now let's go to 30, right? So we run this with 30 and we get even lower profit, 11. So you can see that the window affects the profit a lot, and you can go ahead and play with it, although playing with it too much might create overfit, so you have to be careful. Another important thing is that we chose here SPY and Amazon, and they gave us 0.04. That's the p-value of the Dickey-Fuller test, but not every two shares will provide such a good spread, such a stationary spread, and your job is to go ahead and find the right pair that have a good value of spread that you can work with for pairs trading. This is actually the hardest job here. Okay,